In this video, I'll finally explain the purpose of the dihedral on airplanes. Yes, the angle of the wings from the front. Believe it or not, that's one reason airplanes are so safe. And in this video, you're finally going to understand why high-wing airplanes have negative dihedral and low-wing airplanes have positive dihedral. Today we'll discuss various aircraft wing configurations, and you're going to understand the aerodynamics that govern them. As always, we'll relate this to existing aircraft on this channel. Will you understand why the F-4 Phantom has such an unusual dihedral? Why, for example, World War II planes. Did World War II fighters like the Spitfire and P-51 use positive dihedral? Why, for example, do cargo planes like the C-17 or the Antonov use negative dihedral? After this video, you'll fully understand. Let's begin. The positive dihedral wing design generally stabilizes an aircraft. However, we first need to define stability before continuing. I've already made several videos on this channel talking about it. I'll leave them in the corner, as you already know. But the essence is that if an aircraft is stable, if it's flying and gets disturbed, it will automatically on its own, without the pilot doing anything at all. It will correct itself and return more or less to the path it was on. The example I've always used to teach this. What does it mean for an aircraft to be stable? It means if an aircraft turns suddenly while moving. If the aircraft's center of gravity is ahead of the wings during a turn. In this way, the angle of attack of the wings obviously increases, and this naturally causes, because the wings are behind the center of gravity, as the lift increases, the aircraft will create a moment that lowers the nose, meaning it will self-correct the disturbance to the aircraft. What does it mean for an airplane to be stable, considering it has 3 axes, pitch and roll? And it may be stable on one axis, but not the other. So does dihedral make you laterally stable for yaw and overall? For these two, they're connected, as I've discussed on this channel. Let's examine how dihedral affects an aircraft's lateral stability. I've seen several explanations of this on the internet. Some are not correct, others are, but generally the ones that are correct aren't very pedagogical. So let me try to tie everything together for you so you can understand it perfectly. I've made this square, ugly aircraft design with vertices, but it's perfect for explaining the dihedral effect. The incorrect explanation people usually give is that when we have an aircraft moving straight and suddenly it gets disturbed to one side. If there is positive dihedral, the wing that is lower has more projection on the horizontal axis compared to the other wing, therefore it generates more lift. This may seem true at first. The first time I saw this explanation, I thought it might make sense, but it doesn't. A plane moving against the air doesn't care about the ground. If I removed the ground beneath it, the plane wouldn't notice. Both wings generate the same lift force. If both wings are generating the same lift force, it doesn't matter at all how they're projected onto the horizontal axis. The only thing that will happen is that the wing that's lower will counteract the weight, while the wing that's higher will generate a component to one side. Since both generate the same lift force, the plane wouldn't rotate or self-correct if lift on both wings is equal. This explanation is incorrect, so let's look at the correct one. For that, as I was saying, we're going to use my square plane to make sure you understand what I'm going to explain next. So imagine we have my straight plane flying and suddenly the angle of attack increases. The angle of attack increases. That means from the wind's perspective, as it moves toward the plane, it will see more of the plane's underside. That's important. You'll see why. Since if we now have a plane that is disturbed laterally, let's say it's flying straight and suddenly turbulence puts it like this. When this happens, the plane's total lift slightly favors one side. That means the plane moves forward quickly. There's also a small component on one side. This is called slipping. Well, when this happens, if we look at it from the air's point of view, just like before, it's as if the plane keeps moving straight, but now the wind is coming a little bit from the side. From the air's perspective, one wing has a higher angle of attack than the other. And this difference in angle of attack is what literally makes the plane turn and correct itself. It's important to understand that while the angle of attack rises on one wing, it decreases on the other. In other words, the lift is decreasing a bit. Therefore, the difference between the wings is significant. On the other hand, negative dihedral, the opposite dihedral, known in English as anhedral, has the opposite effect, meaning it has a destabilizing property. The same analysis explains it. The plane flies straight, then is suddenly disturbed. The lift now tilts slightly to one side, so the plane moves forward and slightly in that direction. So it's as if the air is now seeing the plane from this direction. And here you can see that this wing has less angle of attack than the other one. So this will tend to make the plane turn more and more until it gets out of control and it spins all the way around and falls. That would be the extreme case, but it's important to understand that due to the geometry, this is what would naturally happen. Alright, now let's talk about the next most interesting thing. If you notice, all cargo planes like the Antonov 225 are examples. The B-52 is also impressive. All planes that are going to carry a lot of weight and have high wings have negative dihedral. So, are you saying, Sergio Hidalgo, that the Antonov 225 was intentionally designed to be unstable? What are you telling me? Yes, but there's a catch. Because high-wing airplanes, just by being high-wing, already tend to be very stable laterally. Low-wing airplanes are the opposite. Low-wing airplanes tend to be unstable. Just because their wings are low, the explanation for this is amazing to me. Let's get into it. When a low-wing airplane is disturbed, it begins moving slightly to one side. Air approaches at a slight angle from one side, creating a pressure zone on the fuselage where it strikes, and low pressure on the fuselage's other side. This, in the end, would generate a torque in the plane that would tend to turn it more, and as it turns more, the plane would move further to that side. As it turns, more wind hits it, increasing pressure and causing the plane to turn even more. As you can see, you lose control because the wings are on the bottom. Of course, obviously this would be the extreme case and it wouldn't always happen, but in high-wing airplanes, exactly the opposite happens. If we have the airplane flying and suddenly it gets disturbed, like this, it's going to turn to one side. And when it turns to that side, the air comes from that same side and hits the fuselage, creating a pressure zone. That pressure zone, what it does is generate a torque in the plane, which counteracts it and puts it back in its original position. So yes, like I was saying, having high wings tends to make the plane laterally stable. So what are you telling me? How can a plane with high wings be stable, but become unstable if you add negative dihedral? Why do this? What's the reason? Well, the truth is that most likely the reason why high wings are used on planes isn't to give them more stability. In the A400M, the wings were likely mounted on top to allow more space between the propellers and the ground. The same likely happened with the Antonov 225 or C-17. You want a large distance from the ground, so you place the wings on top. But then maybe your aircraft is too laterally stable. So when the pilot wants to turn to one side, the aircraft either doesn't respond, or do you need really big ailerons? Therefore, to avoid these problems, you make it have negative dihedral, and that way it's gonna be a little more unstable. This ultimately benefits you. Low-wing airplanes have the opposite effect. If you design a fighter plane like a Speedfire, P-51, or F-4 Corsair, any airplane from World War II, you'd probably want it to have the wings down low. There are many reasons why you'd want to have the wings down low on this type of airplane. We'll likely make a video about this later. The point is, designing an airplane with low wings likely makes it more unstable than desired. So you design the wings with a positive dihedral, which improves stability. The Harrier, for example, needed top-mounted wings to enable vertical takeoff. Since the nozzles that are in the middle of the plane have to blow air downward, obviously the nozzles have to be below the wings, because if not, when blowing air downward, they would hit the wings. With the wing, right? In the Harrier, selecting the high wing setup requires more instability for better maneuverability, so you use negative dihedral. What I want to show you with this is that the decision about which wing configuration to choose probably comes down to the type of mission the aircraft is going to carry out. As I was saying, the A400 absolutely needs to have high wings. The EF4, for example, has a kind of really strange positive dihedral. They probably designed the aircraft that way, but after finishing, realized it was more unstable than expected and said, how do we fix it? Well, obviously we're not going to change the whole aircraft, we just give it a bit of dihedral and that's it. It's like a small fix that greatly improves your aircraft. It's also true that there are other aircraft where, yes, it's very important to have that extra bit of stability. For example, an aircraft where people will fly or learn to fly for the first time. It's very important for it to be stable, or a passenger plane that's going to carry a lot of people. Well, of course, it's also important for it to be very stable and not have any problems. One key point is that the wing's dihedral angle tilts the lift force, so it doesn't just go upward. So the wing's lift force must be slightly more than what you would need if the plane had completely straight wings without dihedral. However, adding a small dihedral angle greatly increases stability. And in the end, it's worth it to lose that little bit of extra lift you have to generate. Lastly, I wanted to mention airplane stability. Results from solving these equations. The magic is that for all airplanes, these equations are the same. These equations are used for every airplane that exists. Within these equations, values change based on your aircraft and selected profile. You use for the aerodynamic profile. I don't know the surface area, aspect ratio, or length of the aircraft. These values are used in these equations. And they tell you if it's going to be stable, if it's not going to be stable, if it's going to be very unstable, and so on. I'm showing you this so you can see it's truly complicated. It's not like they just start designing and say, oh no, maybe a little more dihedral. Of course it's not like that, okay? After solving these equations, if more stability is needed and a dihedral angle could help, it's added. If you want, I can also talk about these equations, explain them a bit more in depth, let me know down in the comments. I hope you enjoyed the video and understood the dihedral topic. Before this video ends, I want to suggest a challenge we could do on Twitch, in which you tell me the names of airplanes and live, I show a picture and say, look, I think this plane has positive dihedral because of this, this, and this. Or look, I think this plane has a high wing because of this, this, and this. You know how it goes. If you like this idea and think it could be interesting, let me know in the comments below. Follow me on Twitch and Twitter for live updates. You can also follow me on Instagram or LinkedIn. It's been a pleasure having you, and I'll see you next time. You already know. Science lead.